What is the coefficient of friction between this shoe and the tabletop? We're going to find out in this video. But first, let's look at an example of a wood block. What is the coefficient of friction between this wood block and the table? To find the coefficient of friction, we need to know the friction force and the normal force. To find the friction force, we're going to drag this block horizontally at constant speed. At constant speed, the forces horizontally are balanced. The applied force is equal to the friction force. So I'm going to pull on this at constant speed, and you can see at constant speed that the applied force is about 0.55 newtons. Therefore, the friction force is also 0.55 newtons. Now, what's interesting about kinetic friction is that the friction is constant. So it doesn't matter what my speed is. But if I pull it at constant speed, then I can use this reading, the applied force, and that will tell me what the friction force is because the forces are balanced when the object is moving at constant speed. The next thing I need to know is the normal force. To measure the normal force, I know that when it's at rest, the forces are balanced. So the normal force, the force from the surface pushing the block up, is equal to the weight of the block. So if I can figure out the weight of the block, I can figure out its normal force. So I'm going to use the same spring, and I'm going to hold it up now. And then we're going to look at the number right here. And we can see that the block weighs about 2.65 newtons. Now, using the normal force as well as the friction force, we can calculate the coefficient of friction. Here is the force diagram for the block being pulled to the right. And if we pull it to the right at constant velocity, then we know that the forces are balanced. And so the applied force to the right is 0.55 newtons. That's going to equal the kinetic friction force, which is also going to be 0.55 newtons. The weight of the block was 2.65 newtons. And since it's not accelerating vertically, these two forces have to be balanced. So we know that the normal force is also 2.65 newtons. To calculate the coefficient of friction, we know that the equation for the kinetic friction is equal to the coefficient of kinetic friction times the normal force. So the coefficient of friction is just equal to the kinetic friction divided by the normal force. And the kinetic friction is 0.55 newtons. The normal force is 2.65 newtons. And we get approximately 0.21. And that's the coefficient of friction between the block and the table. To understand friction, I like to use this hand demonstration. If you place your hand close together and you kind of move it side to side, it's pretty easy to slide it across each other. But if you push it against each other real hard, it's really hard to slide, and there's a lot of friction. So when we think about friction, there's two things that affects friction. One is the surface. How rough is the surface, which is going to be the coefficient of friction. And the second is how hard the two surfaces are pressed against each other, because when they're pressed against each other really hard, it's hard to really move them and slide them. And so that's represented by the normal force. The normal force tells us how hard the two surfaces are pressed against each other. Let's try another experiment. What do you think would happen to the friction force if we place this hook mass on top of the wood block? We're going to use the same surfaces here. So we have the wood block and the top of this table surface. And so the coefficient of friction is going to be the same. What is different is how much the surfaces are pressed against each other. So the normal force is much greater when I put this hook mass on top of this wood block. Now, without the hook mass, the friction force was about 0.55 newtons. Now, with the hook mass, let's go ahead and pull this in at a constant speed, because at constant speed, we know that the applied force equals the friction force, and we get about 1.7 newtons. So much greater than the 0.55 newtons. Now let's take a look at what happens if we change the surface. So instead of pulling this block on the tabletop, we're going to pull it across this sandpaper. And if you remember, on the table, the friction force was 0.55 newtons. Now we're going to pull it across the sandpaper at constant speed, because at constant speed, the applied force is equal to the friction force. And as I pull it, I can see it's about 1.3. It varies a little bit, but about 1.3 newtons. So on the sandpaper, that changes the coefficient of friction because you're changing the surface. And so the friction is greater because the coefficient of friction has increased. Now we're going to calculate the coefficient of friction of the shoe. The first thing we need to know is the kinetic friction. Now I'm pulling at constant velocity, so I know that the pulling force is equal to the kinetic friction, and the pulling force is about 0.7. The next thing I need to know is the normal force. Now on the table, the normal force is equal to the weight of the shoe, and I'm going to pull this up here to get the weight of the shoe, and the weight of the shoe is about 2.7 newtons. Using this information, I can calculate the coefficient of friction, which is just the kinetic friction divided by the normal force. So 0.7 divided by 2.7 newtons, and we get 0.26 is the coefficient of friction. It has no units because the newtons cancel out.